Hello, class. In this example, we want to solve this differential equation, x squared times y double prime minus 3x times y prime plus 3y is equal to 2x to the fourth times e to the x. So for us to do so, we first need our auxiliary equation. So applying that for this would be m squared minus 3m plus 3 is equal to 0. So solving that, we could factor this. This becomes m minus 1 times m minus 3. Would be equal to 0. So in doing that, I just noticed there's a mistake with it. This needs to be a 4. And a 4 here. There we go. Anyway, for us to actually do this then gives us two real solutions, m being 1 and 3. So this gives us a complementary solution as c sub 1 times x plus c sub 2 times x cubed for this Cauchy-Euler equation. So the standard form of this, by dividing by x squared, gives us, let me just label this being a standard form. Is going to be y double prime minus 4 over x is y prime plus 3 over x squared times y is equal to 2x squared times e to the x power. So in doing this, we have f of x to be 2x squared times e to the x, y sub 1 to be x from a complementary solution, y sub 2 to be x cubed, also from a complementary solution. So we can write our Wronskian, x cubed, 1, 3x squared. Doing this calculation gives us a determinant of 2x cubed. For w sub 1, this would be 0x cubed, 2x squared e to the x, and 3x squared. Calculating this determinant gives us 2 negative, more space, negative 2 times x to the 5th times e to the x. And for w sub 2, this one gives x 0, 1, and 2x squared e to the x. So this determinant is 2x cubed e to the x. U sub 1 prime is going to be, this is negative 2x to the 5th times e to the x divided by 2x cubed. So this simplifies slightly to be negative x squared times e to the x. And for u sub 2 prime, this one cancels a bit more. 2x cubed times e to the x divided by 2x cubed. This 2x cubed cancel, and we're just left with e to the x. So we need to integrate both of these to get our functions. So for u sub 1, integrating this negative x squared e to the x dx. This requires two uses of the integration by parts, but after doing all that, we would get negative x squared e to the x plus 2x e to the x minus 2e to the x. And for u sub 2, this would be integrating e to the x dx, which just gives us e to the x back. So our particular solution for this is going to be u sub 1 times y sub 1 plus u sub 2 times y sub 2. So in our case, this is going to make this one negative x squared e to the x plus 2x e to the x minus 2e to the x. That times y sub 1, which was x, plus we would have e to the x times x cubed. So that's slightly, very slightly combines to make 2x squared e to the x minus 2x e to the x based upon the these functions. So our complete solution, y would be equal to the combination of that complementary and particular solution. So c sub 1 times x plus c sub 2 times x cubed plus 2x squared e to the x minus 2x e to the x. So let me know if you have any questions or concerns. Thank you.